So, hello, my dear friends. How are you all? Once again, you are very welcome in our lecture number 6 of real numbers. So, friends, I hope you will enjoy this lecture. So, friends, now without wasting the time, let's start. Okay, so, friends, now today we will discuss properties of real numbers. What is? Yes, properties of real numbers. Okay, so you already know about real numbers. What is real numbers? What are the types of real numbers? Okay, in previous lectures and in the beginnings, you already learned about all the all about the real numbers. So here we are just discussing about the properties of real numbers. Okay, yeah, now let's start. So our first property is that, yes, so the first property is closure property of addition. What is? Yes, closure properties of addition. In this case, the sum of two real numbers is always real numbers. Means if we add a plus b, we get c. It means a plus b is a real and the result is c, which is also a real numbers. Okay. Now, next property is that commutative law for addition. Commutative law for addition. Now, listen to me very carefully in this case. In this case, if we add two numbers, if we add a plus b, okay, and if we add like this b plus a, so the result will always be same. Okay, so the result will always be same for whole real value where a and b are what? Real numbers. Okay, I hope you get this point. Now let's come on the third properties. These are very small properties. Okay, so associative law for addition. Associative law for addition. Now associative property. What is associative property? I will explain you. Associative law for associative law for addition. Okay, so what is associative says that in this case, if we have a three numbers, let's suppose a, b and c. Okay, so these three numbers are real numbers. Okay, now if we add, yes, if we add like this, like if we add first two numbers and then third number, or we can add like this, if we add last two numbers, if we add last two numbers and then we can add the first number, then the result will always be same. This is associative law for addition. Okay, I hope you get this point. Now next property is existence of additive identity. Additive identity. Okay, so what is additive identity? The additive identity is that if in a number, if we add 0, then we get the same number. Okay, so if we add a plus 0, then 0 plus a, we always get a. Okay, so A is our real number. So 0 is the additive identity. Okay, so this is our additive identity property. Yes, now let's move on. Our next property is that a sixth property, existence of additive inverse. Existence of additive inverse. Okay, so what is additive inverse? Additive inverse is that if in a number, if we have A as a real number, it is a real number. Okay, if we add a number in A which gives the result 0, that the number is called additive inverse. Like if we add in this number like minus of A, negation of A, then we get 0. So this minus A, this minus of A, this negative of A, this is our additive inverse. It means AI means additive inverse. Okay, so there exists a real number minus A, so that A plus of minus A is equals to 0. Okay, so I hope you get this point. Now let's move on. So next property is that closure property for multiplication. Now here is the difference. Closure property for multiplication is that closure property for multiplication. Okay, now in this case, if we product two real numbers, then we get also a real numbers. Then we get always a real numbers. Okay, where A, B, C are real numbers. Now next property is that commutative law of multiplication. Here we saw that commutative law for addition. Now here we see that commutative law of multiplication. Commutative law of multiplication. Okay, so now let's change the color. Okay, yes. In this case, if we multiply A and B, A into B, or we can also multiply B into A, then we get a same result. Okay, here is also A and B are, yes, A and B are what? Real numbers. So our next property, ninth property is that associative law of multiplication. Okay, in this case, if we multiply A multiply B and then multiply C, or if we multiply B multiply C, like B multiply C then A, then the result will always be same. This is our associative law of multiplication. Okay, now existence of multiplicative identity. Now in this case, existence of multiplicative identity. Okay, so friend, What is multiplicative identity? 1 is called the multiplicative identity because if we multiply 1 in A or A dot 1, then we get A, means we get the same number. So 1 is the multiplicative identity, means MI. Now 11 property is that existence of multiplicative inverse, existence of multiplicative inverse. Multiplicative inverse. Now in this case, every non-zero real number A has its multiplicative inverse like this. If A is multiplied by 1 upon A, then we get 1. Okay, so the inverse is called the multiplicative inverse. Okay, I hope you get this point. Now the last property is that distributive law. Distributive law of multiplicative multiplication. Distributive law of multiplication over addition. Okay, now in this case, if we have a three number A, B, C, so the distributive law means in this case we distribute the numbers, like if we multiply A into B plus C, in this case what we do, we can do A multiply B plus A multiply C. So this is the distributive law. In this case what we have to do, we have to distribute the numbers, like we are distributing like A multiply B, means we are distributing with B and C both. Okay, okay, I hope you get this point. Now so now let's move on. Yes, test of divisibility. Test of divisibility. So what is saying that in this case we are seeing that, now first case is that divisibility by 2. We are seeing in this case that divisibility by 2. So what is the conditions of a number which can be divided by 2? So that the condition is that divisibility by 2. In this case, so the divisibility rule is that if the unit digit of a number must be even. Okay, so the unit digit of a number must be even. Unit digit is that what? Like if we have a number 2, 4, 6, 3, 8. So the first digit from the right is the unit digit. Is the, yes, is the unit digit. So the unit digit is what? This is even. So we can divide whole number by 2 very easily. Okay, so this is the divisibility by 2. A second case is that by 3. So what is the rule? So the rule is saying that the sum of digits of a number must be divisible by 3. Means if we have a number like this, if we have 24, okay, so we are doing the sum of digits, means 2 plus 4 we get 6. So 6 can be easily divided by 3. So 24 is also can be divisible by 3. I hope you get this point. Okay. So the third condition is that divisibility by, I'm not writing divisibility again and again. I'm just writing by. Okay. So you have to understand yourself. Okay. Divisibility by 4. So what is that condition? So the number formed by last two digits of a given number must be divisible by 4. Okay. Means if we have a number, what, like this, 1, 2, 2, 4, means in this case, if the last two digits, means last two digit, if last two digit is divisible by 4, then we can easily divide whole number by the 4. I hope you get this point. So the number formed by last two digit of a given number must be divisible by 4. Okay, I hope you get this point. Now our next point is that divisibility by 5. So in this case, if the unit digit, is 0 or 5, then we can divide that number. Like if we have 2, 6, 3, 5. So the unit digit is what? This is 5. Okay, so we can divide it by 5 whole number. Okay, now fifth, this divisibility by 6. Okay, so in this case, the given number must be divisible by 2 or 3. So the given number must be divisible by 2 and 3. So that's why so that is the rule in which we can divide the whole number by the 6. If that number is divisible by 2 and 3, then we can divide that number by the 6. So the rule of 2 and 3 we already know about this. Okay, so the sixth rule is that divisibility by 7. So here is the case that subtract 2 times of the unit digit from the number formed by excluding the unit digit from the given number, then the result obtained must be 0 or divisible by 7. Okay, in this means it is saying that we have to subtract 2 times the unit digit from the number given formed by excluding the unit digits. Okay, so we have to subtract the unit digit. Okay, like 49, we have to subtract the unit digit 2 times, subtract 2 times of the unit digits, okay, from the number. Okay, I hope you get this point. By excluding the unit digit means we have to exclude the unit digits, and the result must obtain 0 or divisible by 7. So that's why that number can be divisible by 7. Okay, let's move on. So the next case is that divisibility by 8. So in this case, the number formed by last three digits of given number must be divisible by 8. Okay, so if we have a number 2, 4, 5, 6, 8, if last three digit number is divisible by 8, then we can divide whole number by 8. Okay, next is by 9. So the condition of 9 is that the sum of digit of a given number must be divisible by 9. Okay, if we have a number like this, what? Yes, if we have a number 63, if 6 plus 3, 6 plus 3 is 9, 6 plus 3 is 9. Sum of digits. Sum of the digits can be divisible by 9. So the whole number is also divisible by 9. So this is very easy. Now, case number 9. In this case, by 10. 10 is very important. 10 is very easy. The number which have the unit digits is 0. So it can be easily divisible by 9. Okay. So there is no concept. So the 10th concept is that divisible by 11. So in this case, the difference between the sum of the digits at even and odd places must be 0 or multiple of 11, or multiple of 11 means in this case, if we have a number 2 4 5 6 7 8, so the difference of sum of odd places and even places numbers means if we have three numbers, if so we have odd number places, even number places numbers 2, 5 and 7 means 2 plus 5 plus 7, and the difference of 4 plus 6 plus 8, 4 plus 6 plus 8. If this difference, what is the difference is that 2 plus 5 plus 7 is what? 7, 7 plus 7, 14 minus 4 plus 6, 10, 10 plus 18 means we have minus, okay, minus 4. So if the result is 0 or multiple of 11, then we can divide the number by the 11. So the result is different, so we cannot divide it by 11. So I hope you get this point. Now, divisibility by 12. 11 point by 12. Okay. So the number must be divisible by 3 and 4. If the number is divisible by 3 and 4, then we can easily divide that number by the 4. So 12 point is that 13 by 13. What is the condition? Add 4 times of the unit digit to the given number formed by excluding unit digit, then the result obtained must be divisible by 11. Okay, so add 4 times of the unit digits, 4 times of the unit digit to the given number formed by excluding unit digits. Okay, so then the result obtained must be divisible by 13. Okay, so if we have a number 2 4 5 6 7, if we add 4 times of the unit digit is what? 7 to the given number. Okay, to the 4 times of unit digit is added to the given number by excluding the unit digit, means we have to exclude the unit digit, means 2 4 5 6. Okay, 2 4 5 6. Okay, okay, if the result is the multiple of 13, okay, then the result obtained must be, so if the result is divided by 13, then this number can be divided by 13. Okay, I hope you get this point. So friends, now let's move on. Yes, now we are studying about radicals. What is radicals? So an expression written under a radical sign is called a radical expression. Means an expression where we are returning the radical signs. So this is called the radical expression. So the radicand is the number under the radicals. Okay. For examples, under root 5, 3 root 7. These are the radicals. 1 upon under root 3. Okay. So these are the radicals. These are the under the sign of radicals. Okay. Yes. So a surd is the simplest type of irrational number. So this is a surd, which is a simplest type of irrational number, one whose radicand is a rational numbers. Okay, so the order of surd is indicated by its index. Okay, the order of a radical is the denominator of its fractional exponent. Is the denominator of the fractional exponent, like this. Like if we have a number a under root n, so the order decides the, so this number decides the order of the third sum. So the order is the third of nth order, means it is the third of nth order. Okay. Okay, so it is divided into, it is divided into four parts. Like first part is that, what is first part is pure third. Pure third, in this case, what is pure third? A third in which the whole of the rational number is under the radical sign and makes the radicand is called pure third. For example, listen to me very carefully. For example, under root 8, cube root of 15. Okay, like this, etc. Okay, now second type is that mixed third. Mixed third. What is mixed third? Mixed third, if some part of the quantity under the radical sign is taken out, okay, is taken out of it, then it makes the third mixed term. Like this, 3 4 times under root of 2. Okay, now next example is 4 under root 2. Like this is a mixed third. Okay, now the third type is like third. Like third. Like third means similar thirds. So what are like thirds? The thirds having the same irrational factors are called similar thirds or like thirds. For example, root 3 and 5 root 3. So the factors are root 3 and root 3 are same, or 2 upon 5 root 3. These are like third. So unlike third are, what are unlike thirds? Unlike thirds. So the thirds having different irrational factors are called dissimilar thirds. For example, root 2, 2 root 3, 2 root 5 are the unlike thirds because they have no common factors. Okay, so now, yes, we are having some examples. So now this number we have to convert into mixed third. How we can convert it? So like this. So we have 1875. So if we do the factors, we get 5 raised to power 4 into 3. 5 raised to power 4 into 3. Okay. Now 1875 is equals to 5 raised to power 4 into 3. Now we get 5 under root 3. So this is our mixed surd. Now we have to convert into pure surd. So now we can easily convert. We can easily convert like this. What? 3 times 3 raised to power 3 into 7. Simple. Okay. Yes, this is in the pure surd. If you solve it, then you can also convert into the pure surd. Okay. So now let's move on. Yes. Rationalization of denominator. Okay. Sometimes we come across expression containing a square root in the denominator. Sometimes we have an expression in the denominator which is okay, which is a square root, which is in the form of square root. So the addition, subtraction, multiplication and division of such expression is convenient if their denominator are free from square roots. Okay. So we can easily add multiply division. Okay. Which is very convenient if the denominator are free from square root. So to make the denominator free from square root, we have to multiply the numerator and denominator by an irrational number, which is called the rationalization factor. Okay. So first of all, like if we have a number 1 upon under root a, okay, 1 upon under root a plus b, 1 upon under root a plus b. Okay, so in this case, in this case, the addition of this number is very difficult. The addition of this number or to the solution of this number is very difficult. So for solving this number, we have to multiply and divide to their opposite irrational number like this: under root a minus b upon under root a plus b. So this is the rationalization. This is the what? Yes, this is our rationalization. This is the rationalization of denominator. Rationalization. Let's do an example. Yes, we have 1 upon 3 plus under root 2. If we divide and multiply by 3 minus under root 2 upon 3 minus under root 2. Okay, so what we get? We get in the numerator there is 3 minus under root 2. This rationalization is always valid in the denominator when the denominator is in the form of square root. Okay, so this is a plus b and a minus b formula. So we can write here 3 square minus a square minus b square like this. So the result is 3 minus under root 2 upon 3 3 is a 9 minus 2. So we get 3 minus root 2 divided by 9 minus 2 is 7. So this is our result. So this is the rationalization of denominator. Okay, I hope you get this point. Now, to find the number of divisors of the composite number, let's suppose we have a composite number and we have to find the divisors of that numbers. So there is a direct formula to find the divisors of a number. Okay, so let's suppose we have a number like this, and we are doing this factor. What are the factors? A raised to power p, b raised to power q, c raised to power r. Okay, a b c are prime numbers. Okay, and PQ are the positive integers. Okay, so now if we want n means number of divisors, if we want the number of divisors of capital N, what is the direct formula? So the direct formula is P plus 1 into Q plus 1 into R plus 1. So this is the direct formula. If we want the sum of divisors, okay, if you want the sum of divisors, so what is the direct formula? So the direct formula is that a raised to power p plus 1, this is a plus, p plus 1 minus 1 upon a minus 1 multiply again b raised to power q plus 1 minus 1 divided by b minus 1. Okay, similarly c raised to power r plus 1 minus 1 divided by c minus 1. Okay, so I hope you get this point, how we can find the sum of divisors. So that's the formula. Now next thing is that the product of divisors of n. How we can find the product of divisors? Product of divisors. So what is the direct formula? So the direct formula is capital N in raised to power small n by 2. Okay, so this is the direct formula, where n is number of divisors and n is our main number. Now we have to find, so first of all, first number is that the number of divisors of n. So first of all, we have to find the factors of n. So the factors of n are, means factors of 30 are 2 raised to power 1, 3 raised to power 1 and 5 raised to power 1. So what is n? Small n means what is number of divisors? 1 plus 1, 1 plus 1, 1 plus 1. Here we know that p plus 1 into q plus 1 into r plus 1. And what is pqr? Pqr is 111. So the result is what? The result is 8. Okay, so there are 8 divisors. How? Yeah, we can find out very easily. We can divide 30 by 1 also. 2, 3, 5, 6. This is the verification. 10, 15 and 30. So there are 8 number of divisors. Okay, I hope you get this point. Yes. So now the second thing is that the sum of divisors. Sum of divisors. What is the sum of divisors? So we are doing the direct. So the direct formula is 2 raised to power 1 plus 1 minus 1 divided by 2 minus 1. Okay. Again 3 raised to power 1 plus 1 minus 1 divided by 3 minus 1. So now 5 raised to power 1 plus 1 minus 1 divided by 5 minus 1. So now the result is 2 raised to power 2 minus 1 divided by 1. Okay. 3 raised to power 2 minus 1 divided by 2. 5 raised to power 2 minus 1 divided by 4. If we are solving this, so we get the answer 72. So this is our answer. Okay. Now the third question is, we have to find the product of divisors. So what is the product? So the product is, so the products are, what is the formula? Capital N by 2. Okay. So what is N? Capital N is 30, or this is what? 8 upon 2 means 30 raised to power 4, and if we solve it we get 81,000,000. Okay, so this is our answer. So friends, I hope you get this point. Okay, so now here we are ending this lecture, and now we will meet in the next lecture. So thank you very much for listening me.